नमस्कार बच्चों, मेरा नाम धन्या और हम लोग ग्रेड 11 केमिस्ट्री का थर्ड लेसन कर रहे हैं जिसका नाम क्लासिफिकेशन ऑफ एलिमेंट्स एंड पीरियोडिसिटी इन प्रॉपर्टीज. ओके, सो टुडे वी विल लर्न हाउ टू predict the period, group and block of an element. Okay, so in the last video we learned about some features of the small history about the periodic table, how it was the work of so many scientists, okay, and how they are arranged in increasing order of the atomic numbers. Okay, and in today's video we will be learning, if an element is given, if we know the atomic number, how to predict the period number, group number and block number of an element or the block of an element. And this is a very important question from the point of view of a competitive exam. Okay, so let's start with period number, or how to predict the period of an element. Okay, so the period of an element depends upon the valence shell. Valence shell, I already told you the last shell is called as valence shell. Sometimes they use these terms, so that's why I'm also using valence. Valence shell. Okay, or we can say the largest value of principal quantum number, largest value of n, which is the principal quantum number. I'll show you with an example. For example, if I have a configuration 1s2, 2s2, we learned how to write the configuration in one of the videos by Aufbau principle, right? 2p6, 3s2, because today we will be writing a lot of configurations. Okay, so this is the configuration of an element, and which is the largest value of n here? 3. So the valence shell is 3. So this element is in period number 3. So this is how we predict the period number of an element. Another example, suppose if I have atomic number 26. First, in order to guess the period number, we have to write the configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So 6 more to go. Yes. So what is our period number, which is the largest value of n over here? 4. So our period number in this, for this particular element, is 4. So period number is easy. You just have to check the largest value of n, the principal quantum number. Okay, so although we okay, so period number, I hope it is clear. You just have to write down the largest value of n. Okay, so the principal quantum number, largest value of principal quantum number will give you the period number. Okay, now second one is how to predict the block. How to predict the block number of an element. Okay, so in order to predict the block, we check the last electron goes to which orbital or which subshell. This is what we check, and that will be our block. Okay, for example, if I write the configuration 1s2, 2s2, 2p6, 3s2, 3p3. So here, the last electron is going to p orbital. P orbital is still getting filled. Okay, so our block is what? Block is p block. And what about the period? Which period it is in? Period is, largest value is 3. It is in period 3 and block P, because we need to check the last electron is going to which subshell. The last electron is going to the P subshell. And so our block is P and the period is 3. That is the largest value of N. Okay. This is one example. Another example, if I take, if I have atomic number 19. Okay, so first let's write down the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. So, what is our, you need to tell period number and also the block. 2 questions. Period is the largest value of N. What is the largest value of N for us here? It is 4. And what is the block number? How to check? The last electron is going to which subshell? So it is going to the, see, the s orbital is still getting filled. The last electron is going to the s subshell. So our block is s block. Okay. So this is how we predict. Another example, let's take example 3. Suppose if I have atomic number of 26. Okay, so let's write down the configuration. Let's write down the configuration. 1s2, 2s2, 2p6, 3s2, 4p6, 4s2, and 3d6. Okay, so this is our configuration. Now let's check the period number. Largest value of N, it is 4. So the largest value is N. So period number, largest N value. N is the principal quantum number. Okay, then block. You need to check the last electron is going to which subshell. Here, if you have a confusion whether the last electron is going to the S subshell or D subshell, okay, we can use the N plus L, we can use the N plus L rule. Okay, N plus L rule, whichever has the whichever has more N plus L value, the last electron goes to that subshell. For example, so L values I'll just write 0, 1, 2, 3. 0 is for S, 1 is for P, D. Okay, so for 4S, what is the N plus L value? For 4S, the N plus L value is 4 plus 0. That is 4. For 3D, what is the L plus L value? 3 plus, what is the D value? D value is 2, which is equal to 5. Right? So 4S has N plus L value 4, 3D has N plus L value 5. So who is, which one has a greater value? 3D. So that means the last electron is going to D orbital. So that is why our block is D. So larger value of So the last electron enters the subshell with greater n plus L value. Okay, so if you have a doubt, you can always confirm like this. Okay, right. Then the next one, so we have period number is the largest period number. That means period number you determine with the largest n value. Group number you determine with the last electron where it is going, to which subshell it is going. If you have a confusion, you check with n plus L rule. Okay. Now coming to group number. Next one is group number. Okay. Now for this, for group number, first you have to check the block, whether it is S block, P block, or D block. Okay. For example, if it is S block, okay, S block means it can be NS1 or NS2. S has a capacity of 2 electrons. So either it can be NS1 or NS2. Okay. So if it is NS1, that means the group number is 1. If it is NS2, group number is 2. But this is for which block element? S block element. Okay. Now, if it is a P block element, so that means if last electron or valence electron enters P subshell, then the group number is determined by this, a small formula equals to, group number is equal to 12 plus number of electrons in P subshell. We will do an example. P subshell of the last shell. We will do an example. Okay. So if we find out that the electron is from P block element, so this is the formula we use. Okay. For example, if we have, suppose, atomic number is 19. Okay, we have atomic number 19. We write down the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So, in this case, if you see, it is 4s1. So that means the block is S block. And if it is S block, if it is NS1, what group it is in? Group 1. So this is NS1. So that means this is in group 1. NS1. So that means it is in group 1. If it was NS2, then it would have been in group 2. Right? So this is block is S and group number is 1. How do you determine? Because you check the block is S block. And for S block, the rule is simple. If it is having the configuration is NS1, then it's group 1. If it is NS2, then it is in group 2. So in this case, it is in NS1. So that means it's group 1. Now, and what is the period number? Because we learned the period number also, right? The largest value of n, principal quantum number, 4. So for this particular element, we got all of them, period number, group number, and block number. Now, coming to another example, where Z is equal to 35. Okay, we start with writing the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So, first start with the period number. Largest value of n is 4. Now, block number, last electron enters where? Here clearly you can see 4p, it is getting filled. 3d is fully filled. So 4p is still getting filled. So the last electron enters the p subshell. So it's a p block element. Now for p block element, what is the formula we have? What is the formula for p block element we have? If it's a p block element, what's the formula we have? The formula is group number equal to, if it's a p block element, we determined that it's a p block element. So the formula is 12 plus number of electrons in the p subshell of the last cell. So definitely this 4p5. So how many electrons are there in this 4p subshell? 5 electrons. So 12 plus 5, that is 17. Okay, so that means this element belongs to the 17th group. So this is how we determine the period, block, and the group number. The group number, if it's S block or P block. Okay, so this is the group number, how we determine if it's an S block element, you just have to check NS1 or NS2. If it is NS1, it is in group 1. If it is NS2, it is in group 2. In case of P block, if you come to know that the element is in P block, it's a P block element, then you just have to add on 12 plus number of electrons in the P subshell of the last shell. So we just did an example. Okay. Now, students, in case if it's a D block element, okay, if it's a D block element, so students, I'll just write down the details over here. For group number, okay, if it's a S block element, what do you do? If it's NS1, it is group 1. If it's NS2, it's group 2. Right. In case if it's a P block element, if it's a P block element, how do you determine the group number? There's a formula, 12 plus number of electron in the P subshell of the last shell. Till now, we have learned this about group number. Okay. Now, coming to if the block is a D block. If it's a D block element, how do you determine the group number? Then there is another formula for this. Then the group number equal to, if it's a D block, first you check if it's S block, P block, or D block. If it's a D block, you will use this formula 2 plus number of electron in n minus 1 D subshell. So group number, if it's a D block element, equal to 2 plus number of electron in n minus 1 D subshell. Okay, so this is the formula you will use when you come to know that the element is a D block element. For example, if I have atomic number 43, first we write down the configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d5. Okay, this is the configuration. Okay, we are just applying the off-bow rule: 1s, 2s, 2p, 3s, 3p, 3d. So we are just applying the off-bow rule. Okay, so hope you remember this off-bow rule, how to fill in the electrons. Okay, students, so this is our configuration. Now let's start with the period number. Period number is the largest n value. So which is our largest n value? 5. So that's a period number. Now block. So here you may have a confusion whether it's S block or D block, where the last electron is going. That's how we determine the block, right? So I told you, if you have a doubt, you can always use N plus L rule. Okay, L 0, 1, 2, 3, S, P, D, right? So here 5 plus 0, that is 5 in this case. Here 4 plus, what is the D value? 2, 6. So definitely larger n plus L value is 4D. So that means the block is D block. It's a D block element. Okay, how do you know? If you have confusion, you can use the N plus L rule. So it's a D block element. Now, if it's a D block element, how do you find out the group number? We just have to use this formula: 2 plus number of electrons in the D subshell. That's it. Okay, so D subshell. So here, how many electrons are there in the D subshell? 5. This is 7. So what is the group number of this particular element? It is 7. Okay, so if it's so I'll write it here. So if it's a D block element, we use this formula: group number is equal to 2 plus number of electrons in n minus 1 D subshell, or rather the D subshell. Okay. Okay, so I'm just rubbing this part because all your formulas are here on the right hand side. Okay, so coming to the next example. Atomic number 23. So we write down the configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3D, 1. Sorry, 3D, 3. Now, start with the period number. Period number is the largest n value, 4. Block. If you have confusion, whether it's S block or D block, last electron is going to S or D. What is the rule I said? N plus L. So L, 0, 1, 2, 3. S, P, D. Right. So what is the N plus L value for this 4S? 4 plus 0, that is 4. What is the N plus L value for 3D? 3 plus 2, that is 5. 3 plus 2, that's 5. So who has more N plus L value? D, 3D, right? So it's a D block element, right? So always whenever you have a confusion, you can always apply N plus L rule. Greater N plus L value, the last electron goes there. Okay, so now we have a rule. Now we found out that it's a D block element. So what's the rule? So group number 2 plus number of electrons in the D subshell. How many electrons are there in the D subshell? Is 3. That means this belongs to group 5. Okay, so we will be talking about the exceptions as well. Okay, so first we will discuss about the how to predict the period and group for F block elements. Okay. Okay, students. Now, suppose if an element is F block element. Okay, how do we predict the group number or period number? Okay, now we already learned that F block element, the configuration is experimental. We cannot determine we cannot use N plus L value. So if there is only one way or one trick, if the element has, you check the atomic number. If the element has atomic number between 57 and 71, okay, this is the lanthanide group, okay, and 89 to 103. So they just memorize this range, okay. So this range is the lanthanide range. The second one, 89 to 103, is the actinide range, okay. Suppose if the range is from, if an element has 58 or 59, or so this range element between 57 to 71, this is the lanthanide, and they are in the 6th period. Okay, so you just have to memorize this. And if the element, any atomic number is in this range between 89 to 103, it is in the 7th period. And block, you know, it's F block. If any element has atomic number in this range, 57 to 71 or 89 to 103. So you can directly say that this is F block element. This element is a F block element, and see the range. If the range is between 57 to 71, it's 6th period. If it is between 89 to 103, it is in the 7th period. And all of them, they are in group number is, all of them, all this range element are in group 3. So you just have to memorize this range. And this range, 57 to 71, is the lanthanide group, and it's in the 6th period. 89 to 101 is the actinide elements, and it's in the 7th period, and all of them, they are in group 3. Okay, so the F block is simple. You just have to memorize certain things, that's it. Okay, now coming to some exceptional cases, which is very important, okay, for the competitive exam. Now coming to some exceptional cases or special cases, we can say. Special cases. For example, if I say atomic number 24, this is chromium, okay? So if I have to predict the period number, group number, and the block number, okay, first I write down the configuration as usual. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 4. But we learned before that the chromium is a special case because because of the half-filled d orbitals. We have 3d5 and 4s1 because when any subshell is half filled and or fully filled, it gives extra stability. So for chromium, this configuration is more stable because the d orbitals is half filled. So we have learned about this when we were doing the Aufbau principle and filling up of electrons. Okay, now let's check the period number. Period number is largest n value, which is 4. Okay, block is D. Yes, if you have confusion, you can use the n plus L rule. So L value 0, 1, 2, 3, S, P, D. Okay, so for 4S, it is 4 plus 0, which is 4. For 3D, 3 plus 2, which is 5. So this is 3 plus 2, which is 5. So this is 5. 3 plus 2, that's 5. Okay, n plus n rule. So definitely it's a D block element. Okay, now students. So this n plus L rule is just to confirm. Okay, now it's a D block element. So if it's a D block element, we know how to predict the group number. I have written the formulas at the right hand side. So group number is equal to 2 plus number of electrons in the D subshell, that is 7. Yes, but chromium is not seen to be in group 7. Period number and block number is correct, but the group number is not correct. Okay, it's not in group 7. Okay, because what we have written, so group number is 2 plus 5, which is equal to 7, which is wrong. This group number is wrong. Okay, now students, this is the expected configuration. This is the configuration that makes it half filled and stable. Okay, in these special cases, what do we do? What we do is we always write down for finding out the period number, block number, and group number, we always write down the expected configuration. This is the predicted configuration, and this is the configuration that makes the element stable. But that will give you the wrong group number. So period number and block number is correct, but the group number will be wrong. So in these cases, for finding out the group number, we always write down the expected configuration. Okay, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. This is the expected configuration. But because half-filled subshells are more stable, that's why this electron from 4s goes to 3d. Right. But for finding out the group number, we always write down the expected configuration. So there is no change in the period number. Period number is the same, which is 4. Block is also the same. It's D. See, the electrons are filling the D subshell. Now, group number. Now the group number is 2 plus number of electrons in the D subshell, which is 6. Okay, so this is how we find out in case of these special cases, the group number, where we always write down the expected configuration. Okay, especially those special cases where we had this copper, chromium and all, where the configuration was to make them stable. Okay, so taking another example for this, these special cases are very important, students. Always a lot of questions comes from this part. Okay, coming to atomic number 29, which is copper. Okay, now copper also shows exceptional behavior. We write down the normal configuration. We need to find the period number, block number, and group number. So we write down the configuration that we know for now: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But because copper is a special case where the fully filled orbitals are more stable, we write down the configuration like this. Okay, now period number is largest value of n, 4. Block is S block or D block. N plus L rule. 4 plus 0, 4. 3 plus 2, 5. N plus L rule. Okay, so it's the D block element, right? Now, coming to group number. 2 plus number of electrons in the D subshell. It is 12. But this group number is wrong. Okay, because this is the configuration of copper, according to which this is stable. The D subshell is stable, right? Because fully filled orbitals are stable. That's what we learned. But this is giving you the wrong group number. So in this case, what did we learn? How do we get the correct group number? By writing down the expected configuration. Expected configuration. What is our expected configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 4s2, 3d9. So this is the expected configuration. So the period number is the same. Period number is not affected. It is largest n value. Block is also not affected. It is D. And group number is 2 plus number of electrons in the D subshell, which is 9, so which gives 11. And copper is in group 11. Okay. So these are some special cases. Always write down the expected configuration to get the correct group number. Okay. Now let's do some examples for this. Okay, students, I have written down the formulas over here. Also, please remember the atomic numbers of some noble gases, which would be very helpful. Okay, for example, helium is number of electrons is 2. Okay, and neon, it is 10. Argon, it is 18. Okay, krypton, it is 36. And xenon, until xenon, that's fine, 54. Okay, this is one thing you must remember. Okay. Okay, now coming to the question. You have to find out, I'll give you some elements. You need to find out the period number, group number, and the block number. Okay, So I'll write down the electronic configuration. Okay, you need to predict the period number. Block. All the formulas are there on the right-hand side. And the group number. Okay. Right. First one. 1s2, 2s2, 2p6. Okay. Now, this one is largest period number. How do you find out? Period number is the largest n value, that is 2. And to which block does it belong? P. Right? Last electron enters the P subshell. So, if it is P block, how do you find out the group number? 12 plus number of electron in the P subshell, 18. Right. Second one, if I say 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1. Okay, now n value, the period number is the largest n value, which is 4. Now, okay, now coming to the block number. Block number, you have 3d5, 5, and 4s1. Okay, 3d or 4s. Okay, so I told you, if you have a confusion, you always can follow the n plus l rule. Okay, students, I need some space over here, so I'll just make it a bit bigger. Okay. Okay, so I'll write it like this. Period number, block, and group number. Okay. First one we did, it is period number is 2, block is P, and this was 12 plus 6, which is 18, right? Now, over here, in this case, we have a confusion with 3d5, 4s1. Whether the last electron group, this is clearly the period number is the largest value of principal quantum number n. So that's 4. Now, block number, the last electron is entering the 3d or 4s. So we can use the n plus l rule. So 3 plus 2. So L value is, for L value for D is 2, right? So 3 plus 2 is 5. For in case of S, it is 0. So 4 plus 0 is 4. So the n plus L value, right? So who has higher n plus L value? D. So this is a D block element, right? Now, if it's a D block element, how do we predict the group number? How do we write the group number? 2 plus number of electrons in the D subshell, which is 7. But student, we learned that this is the exceptional case because this is the configuration that we write in order to get the stable configuration of D orbital. But in this case, what do we write? We have to go with the expected configuration, which is what is the expected configuration? 3d4, 4s2. Right? So when the expected configuration is 3D4 and 4s2, our period number and block number will not change. What changes is the group number, which is 2 plus number of electrons in the D subshell, which is equal to 6. This is our answer. This is the exceptional case. This is the chromium case. Okay. So this is how, so please remember the exceptional cases. Okay. Now, coming to the next one is xenon 4F7 5D1 6S2. Okay, so xenon, as I told you, please remember the configurations of some of the noble gases until xenon. Okay, so that means it is easier to find out. Okay, sometimes they write like the xenon, so that means until here the atomic number 54 is covered. Okay, so xenon has an atomic number of 54. So here you can see an F subshell. So in case if you come across an F subshell, okay, period number is the same. Period number, we go with the largest value of principal quantum number, which is 6. So period number, no problem. For block number, if you see an F subshell, okay, you have to check the range. If it is coming in the range between 57 to 71 or 89 to 103. For F block, you need to check this range. Okay, so let's total it. So if you total it, 54 plus 7 plus 1 plus 2. If you total it, it comes to 64. So definitely it comes in the lanthanide range, right? So that means it's an F block element. Okay, and if it's a lanthanide or actinide, the group numbers are the same, which is equal to 3. Okay, so you can directly write it. So this has made it easy. So whenever you come across an F block element, or if you see an F subshell, please total it. Okay, and check if it's coming in these two ranges. Okay. Then the next one. So if it's F block, it's easier. It's easy, right? So you just have to coming to the next example is in case you have krypton 4D10 5s2. So in order to get an idea of the number of electrons until, for example, if they just write krypton, you have to get an idea how many electrons are there. So that's why I asked you to memorize until xenon. Okay. So for example, krypton is 36. So you get an idea there are 36 electrons here. Especially when it comes to F block element, it becomes helpful. Okay. So in this case, the period number is the largest n value. It is 5. Now, in case of block, if you have confusion, n plus L rule. So 4 plus 2 is 6. And this is 5 plus 0 is 5. So clearly it's a D block element. Okay. Now, coming to the group number. Group number is what? 12 plus number of electrons in the, 2 plus number of electrons in the D subshell, which is 12. But this is wrong because this is how many electrons in the, how to predict the group number? What is our rule? 2 plus number of electrons in the d subshell. Okay, so this is 12. Okay, so this is how you predict. Okay, now coming to the next example, I'm just rubbing off these two. If I have xenon 5p6. Okay, period number is the largest n value. It is 5. Block number, last electron is going to the p subshell. Okay, so if it's a p block element, 12 plus number of electrons in the p orbital or p subshell, which is 18. Okay, so if the group number is 18, definitely it will be a noble gas. Okay, now coming to the next one. Xenon 4f0 5d0 6s2. Now the period number is the largest value of n, principal quantum number, that's 6. Now here, first check if it's an F block element or not by checking the by taking the total of the number of electrons. Xenon is 54. Until xenon, it's 54 plus 0 plus 0 plus 2. It is 56. So 56 doesn't come in this range. So it's not an F block element. In this case, you don't have any electrons in the D subshell. Okay, there are electrons in the 6s subshell. So this is an S block element, right? And you have, if it's an if it's NS1, it is in group 1. If it is NS2, it is group 2. So this is NS2, so it will be clearly in group 2. So the group number is 2. Okay, so students, this is how you predict the period number, block, and the group number. Please remember the formulas. Okay, so that's all for today. Have a great day, students.